Hello, everybody. Welcome. Tonight is the 26th of September. You're at Dallas Personal Robots Group, Robot Builders Night Online, virtual. And we're going to do the usual thing, go around the table tonight, talk about mostly robot-y things and sometimes adjacent techie things. We have a queue already that starts off with Doug D, then Pat, then Doug P, then Tom C, and then open mic. So when the guys get into queue, it sounds like we have a handful of interesting robot-y things to talk about. So having started that off, then and Doug P will kind of facilitate things when I'm stepping away here. But Doug D, how's it going in Robo Steampunk Doug land?
Well, things are reasonably good. I'm looking for behind me there. Is this the robot? So you may notice that I keep it up on this table. That isn't always a good plan. I knocked it off last week. It fell to the floor. I said some expletives. I walked away. I wasn't brave enough to look at it. I came back a couple hours later, and I didn't really break anything. All I did was disconnect some of the SR04 wires. So good on that. It's a pretty solid little beast. And I'm mostly done with, you'll see me screwing screws into the background here. I'm almost ready to put these wheels on. Maybe by the end of the day, it'll actually be rolling again. If I didn't disconnect anything inside, it doesn't look like I did. But the biggest update is this cute little thing right here, because Carl and Doug P at the end of last meeting was talking to me about, instead of using VNC and Wi-Fi, I should be using these little Bluetooth controllers. And I looked them up, and it's actually pretty simple to do. And I'm hoping that I will be able to pull that off. And this thing is so little, it will fit in my little glove thing, or as Doug P suggested, some little cavalry glove thing. And that will be a good deal. I haven't actually implemented it, but I did get Amazon to send me one, and they're really tiny. I mean, the thing fits in your palm, really small. They make bigger ones, but I got this little one on purpose. And I've made my list of to-do things so that I can start narrowing down. I got 2 months to go to get this thing operational, so I've got to start checking off the checklist. And other than that, I didn't get a whole lot accomplished because the weather got a little better, and the wife's been dying to get some weeds out of the yard. So I've spent a lot of time in that. They took over, and we're fighting back. I think we're winning. And that's about all I've got.
Hey, Doug, can you give us a close-up of the dog again, just for the heck of it?
Yes, let me disconnect my wire here. This is the dog. Right now, the head is a little wonky because this wire came undone, and it took a bit of the brunt of the problem. I've got the motors on here, and I used my new motor mounting system, and I re-drilled my pin system, because that's how you pull this pin out, and it's going to be on elastic, and you can fold them up and fold them down. And then I've got these wires. Notice the cardboard box stand. That's a bad thing. I'm still using it, though. And I can't open this very much because it's all dark inside, I'm sure. With the legs down, it interrupts it being able to open. This is the head. The SR4 is still in place, but it's kind of wonky. But it's on a little bendable thing here, so that's not a problem. I just hadn't put the backing on it yet, and checked to make sure the camera was in place.
Hey Doug, an idea.
Yeah.
Lose the handles on the first little thing.
You know, I was trying to decide whether that looked good or bad, and I hadn't decided.
Well, lose those first handles, and then make the second handles ears.
Huh. That's an idea. I actually have little antenna-looking things that I'm going to put on the top for ears, sort of like K9 had.
Yeah.
I haven't implemented that yet, but that's my plan.
Mm-hmm.
But you're right. They did. The ones on the back of the other head do look kind of like ears. They're in the right place.
A little bit of fabric or leather or something, and you could really steampunk them out. That's what I'm getting at. You can even give it an earring.
with a gear on it, I'm sure.
Yeah.
A gearing.
One thing that I'm trying to work out, but I doubt if I will get done in time for version 1, which will be what I'm calling the one that goes off the 1st of December, is I want to make a smoky thing, sort of like a vape pen. I've seen some things where people modified vape pens. I've seen things where there's small smoke making things on the Amazon, but they require that the thing be level. And since the thing's going to be riding on my back and then setting down on the ground, that 90-degree shift may be a problem for any liquids inside. So I don't think I'm going to use that liquid smoke generation thing.
Yeah, I'd go for first. I'd also go to the convention because they may have rules about things like, no pyrotechnics and and you'd end up having to take it out.
Right.
So I'm just saying, I don't think it would add much. If you really want to do that, like your idea of you were going to use a recording or something that would make sounds or noises.
Yeah, I'm gonna either do that or I'm trying to do Pico voice recognition so it can give voice commands, but I haven't got to actually playing with that yet.
Yeah. Okay.
That's soon on my list. Everything's got to be soon, but first it has to get operational. And once it's operational, which it should be back again later tonight if I'm lucky, when Carl gets back from whatever he's doing, maybe it'll be rolling. And then I've got to put the encoders back in so they drive straight. And then I get this thing working. And then I forget what's on the list. I'm stepping down the list.
Sounds good.
Doug, I have to tell you, what did you say that thing weighs, like 15 pounds or so?
It's between 15 and 20. I haven't weighed it since it was 15.
But for something that bulky and heavy to survive the drop test to the floor,
I was surprised.
You're doing awesome.
I was surprised. It mostly took it in the box. The back legs took a little bit of it, but they were pretty sturdy. I'm impressed.
Well, that's really good. That's hard to achieve.
I'm not going to try it again.
Don't.
And Doug, I have to say I'm impressed by your use of innovative materials for that dog.
Yeah, thanks. That's mostly on my wife. She's the one that came up with some of the box and the thing for the dog head. My options were much less pretty. I was worried about function, and she's saying, "Well, why don't you do this? Why don't you do that?" I'm glad I got her for many reasons, not just that.
Well, I certainly agree with the reuse of materials on hand. That's what I do a lot of.
Right.
Yeah. Well, that's cool, Doug.
Okay.
It really is.
On to the next one. Who was after me?
I think Pat's in queue. I put the queue in the chat.
Okay.
Pat,
Okay.
then Doug P, then Tom C, then open mic. Yep.
I'm going to go back.
I don't have very much. I was just going to show, I was talking last week about adding a deck to my robot. And
You got it.
you can see I got a second deck added in there. So I got the Raspberry Pi mounted in there. I got a power supply mounted in there. I've got an Arduino and a motor driver. On the top, I'm going to mount the hard drive so I can swap it out if I need be. I'm going to recenter the mast on the top of the robot because it's not between the wheels. It's too far towards the front. And I don't know if I can show that easy. Far towards the front, so it's got to move about an inch back. And then I got to mount a B&O 55. GPS, and I changed my camera to an OpenMV camera, and mount my I'm a flight camera. So it's coming along. I'm trying to get to the stage where it's rolling again. So as has been said many times, get it rolling, get it moving, and everything else starts to fall into place instead of just planning and waiting till something is perfect.
Yeah.
So that's the plan, is to get it back together, get it rolling, and see what I can do.
Yes. Yes. This is when if you had a team, would be really nice, Pat, because while you're doing the mechanical stuff, somebody could have been, could be working on some of the electrical problems that you've got. You know what I'm saying?
Oh, definitely. Would be nice to find somebody, within a couple hundred miles of here that would be able to help.
Yeah.
Sorry.
It's Tom, I don't know, you got more luck down your area in Southern Ontario?
The only robotics like group which is here is far more interested in general electronics rather than robots. So most of my robotic activity is with the several other online robotics clubs that I belong to, besides this one.
Mm-hmm.
Yeah, so like I said, this one as well has been fantastic as far as help, ideas, inspiration, even just somebody to talk through problems with. They've been excellent and top notch. They're the ones that have helped me get this thing rolling last year. And although I don't think I'll make the contest this year, I'm planning to try and at least get it to be able to reach a cone. So
you only need 1 point, Pat. Only 1 point. We had in one of the early years, we had, I think, like a 5th grader who locked up his wheels, like pinned them so that they'd only go there. And he sat back and aimed it just right. And darned if he didn't hit the cone. And he had a bumper. He had a bumper stop. Yeah, he had a bumper stop.
Okay.
Yeah. Now those were a lot shorter distances back then. I think it was probably 100 feet, maybe not even that, 60 feet, but still.
Yeah, well,
1 point.
I'm going to try back here. If I have luck, I may take it out to the area we discussed last year and try to record it and, submit it and get 1 point.
Yeah, hey, yeah. That's all it takes to get started. And
on the plus side, the leaves are already turning orange near the ground.
Yeah. We got, well, I'll talk about it when I get there. That's cool, yeah. I like the look of your robots.
Thank you. I was looking how to add more wood, but it's it's got way too much metal in it.
Yeah, I know.
Wood is good.
Yeah.
That's it for me.
Okay, who's next? Is it me? My turn?
Yeah.
Okay. I don't have chat up, so I don't know. Okay. Let me get rid of some of the little things that I saw that I thought might interest people. So, okay. All right. Okay, there's one thing that I saw that was kind of interesting. It's not really my cup of tea, but some people might find this, something that they could do. It's on Kickstarter. It's called the You Got Robotics Kit, and it looks like it's a robotic kit that allows you to configure it into a wheeled robot, a legged robot, what else? A couple other types of robots. Let's see what this is. Oh, here it is. Spider robot, self-balancing car, Mecanum wheel car. So it looks like it covers a lot of the basic styles. It looks like it has some sort of screen on the front. I haven't really looked to see all of the things. There's still, at least this morning, there was still super early bird kits available. And they have something they call a basic kit and something that they call a full kit. And I really don't know the difference of those either. But because, like I say, one of the things that's kind of, for me, is I enjoy building my own robots. So this type of kit doesn't really appeal to me, but it might to some people. But this one's like $370 for the partial, and looks like it's, you can't see it. Oh, $550 for the full kit. So anyway, I mean, that's kind of rich too, but it might appeal to somebody, you know? And so, I mean, to be able to work with all of these robots forms fairly easily and quickly would definitely be a time saver for somebody who was just beginning in their robots. If they could just switch from type, and I assume they're going to have some sort of basic program. Let's see if we can figure out what sensors they've got. If they've got anything. Well, it looks like it's got motion tracking, speech recognition. Oh, wow, it works with GChat. Gee, I wonder what they mean by that. I guess you ask it a question. It's a graphical Python programming. I'm not sure I like that idea, but you know, I'm sure to make it easy, that's what they had to do. Anyway, so that was one thing I saw that I thought was, you know, like I say, it's got 731 backers already, so that's pretty good. And then this came from Adafruit, and they don't have this available yet, but it's something that you might be interested in looking at. It's a round TFT display. Instead of being a rectangle, it's literally round. I could see certain instances, like if you were trying to do a radar screen, this might be conducive for that. Cost isn't very expensive. They have a touchscreen version of it, and if I remember right, they're run somewhere. Both of them, even the touchscreen, is probably $40. They have a whole series of them. Unfortunately, it also looks like it might require a Raspberry Pi to actually run because of the interface. They use an SPI, but it's apparently only for configuration, not for drawing onto the actual screen. So anyway, I thought it was interesting. So those are two things that I wanted. Now I want to talk about my, let's see here.
Yeah, I don't think she had the driver ready yet for it.
Yeah.
I think. Yeah.
But you all remember whoops, what in the world? You remember seeing this and you realized I had to buy a new laser. Well, this is somewhere with this guy. Nope, that's not it. Where did it go? I had it just there. It's here. Oh, here it is. Okay, so this is my project that I'm building right now, and I've got all the 3D prints parted and all the pieces assembled, and I'm right now in the process of actually drilling these holes here in the corner to mount this top plate. This is a manual. You have in each corner you have essentially a lead screw. And you twist this handle and the stage goes up and down, allowing you to adjust your focus. And in my case, what I would do is put a honeycomb on top of this metal plate and then just adjust it to the top of the metal of the honeycomb. So anyway, I'm very close to this. The only part that I haven't really figured out yet is, and I may have to make it myself, and that's the belt. I'm hoping that when I get finished, I'll be able to source a closed loop belt, but it might not. I might have to use an open belt and do a splice in it. So we'll see. But that's my project that I've been working on this week. And like I say, I hope to have it done today, and I'll probably have it done tomorrow. So anyway.
I see a problem there with having 4 corners instead of 3.
Well, yeah, Dave, but on the other side, they're all adjustable. So as long as you can get this plane flat, you're okay. You know what I mean?
Yeah, but it's the issue of getting it flat.
I've actually haven't. I know what you're saying. I know the theory, but with 3 corners, I still have I still have problems with getting it flat with 3. So, or it's not any harder for me. And with the laser, it's pretty easy to quickly find if you're flat or not. It's just like, you know how, like on a 3D printer, if you had this stage as your 3D printer and you wanted to make sure that the nozzle to plate distance was correct, what you would do is you'd print a big rectangle like this, and you would look at the printed line. And if you're too tight, you may actually skip you can hear your stepper skip. If you're not so tight, you might hear it straining. But if you get it to the point where you have a nice squeezed filament all the way around, then you can print anything in the inside, assuming that the center isn't sunken or bowed. And that's there's no Z-axis adjustment on the K40 laser. So you have to do it with the stage. What I'm doing now is I have a piece of I don't know, I'm just going to call it holy metal. It's metal that's got holes all in it. It's not a honeycomb. It's, I don't have it here, but it's just a sheet of metal with a thing, and it's magnetic. It's steel, so I put space up to my proper focus distance using magnets. So I have a collection of 5mm magnets and 3mm magnets, and I think I might even have a 2mm magnet. But anyway, using those, I can step it up, put my material on top of it, and then use another magnet on top of that of the material. And since the material is usually non-magnetic, obviously, it'll hold it in place, and that works real well. But I've always wanted one of these that goes up and down, so we'll see. Yeah, I'll let you know. There's another thing too. The biggest thing that I see that's a little scary, Dave, is these are 8mm rods. Okay, the bearings are your typical skate wheel bearings, which are 8mm in the middle. So I said these rods aren't 8mm; they're 5/16 because they're imperial. So at 5/16 rods are 7.93 millimeters. So there's a little slop in the bore. And what this design depends upon is there's a nut underneath here, and there's spacers on the inner race. And then when you put the belt gear on top of it, that what you do is you compress it so that wiggle is only the wiggle of the bearing and not the net wiggle of the 0.7mm off between the shaft sizes. So anyway, we'll see. I'll know tomorrow if it works. I'll tell you that.
Doug, just a question. This is for your laser cutter?
Yes.
Okay. Does the controller for your laser cutter employ any form of automatic leveling? And if so, do you find it useful for laser cutting?
No, there's no built-in.
Can't hear you. Looks like you're frozen, Doug. Hello?
I can hear you, Tom.
Okay, I can't hear Doug.
I think he
Yeah,
froze.
it's frozen to me too, so
Okay.
That or he's moving really slowly.
very, very slowly.
Anyway, I have auto leveling on both my 3D printer and my desktop CNC. And for their particular applications, they have proven to be very, very valuable, especially for etching printed circuit boards on my desktop CNC. I wouldn't try to etch them without it. Let's see, where did he go? I guess he'll come back.
So Tom, how do you make your PCB?
Geez, I haven't made one for a while, but basically use something like KiCad to produce the design work, convert that into CNC, and then use a CAM tool to produce the CNC. And then I've forgotten the name of the controller I'm using, a Linux-based controller that I use to control the CNC machine, and it contains auto leveling functions. First of all, I mechanically level the board that I place on the CNC platform. I mechanically level that with a square end mill. That's when I first learned how out of level my CNC machine is. But level the board, clamp the board down, clamp the printed circuit board onto the wooden underlay. And then you realize that printed circuit board material, of course, is never flat. And the leveling function will do a point by point measurement of the XY array of the copper surface of the printed circuit board, and then modify the CNC code in order to follow the actual surface of the copper on the printed circuit board. And that produces excellent printed circuit boards by cutting, by etching, rather than chemical versions. I used to do chemical. I used to use the laser printer and lay the black toner on top of the copper and then etch it and clean it. Used to make them that way, but not anymore. That is when I don't buy them from China.
So have you used a program called Chili Pepper?
I have not, no.
It's a good one. It has that built into it, so you might look at that.
Yeah.
It's very cringy.
One of the downsides of getting older is I can't remember the details without looking them up anymore half the time.
But it's very good. Yeah, you definitely need to have the all level in there, because you'll be amazed at how flat really isn't flat.
Yes. And then do the leveling very carefully, the auto leveling or the auto measurements very carefully, and then use them. So it produces really good circuit boards. I like the fast turnaround on simple boards that I can get that way. The same thing I used to do with the laser printer and chemical etching, but I'm just not comfortable doing chemical etching anymore.
So what program do you use to design the board in?
Again, you've caught me at an elderly moment. I don't remember.
Right.
When I do circuit boards, I do them or schematics, I do them in KiCad. KiCad will then produce a printed circuit board layout for me.
KiCad, okay.
KiCad or KiCad, depending how you pronounce it.
I use a thing called Design Spark Mechanical, and one of the components they have is for tracing boards and that.
Okay, and of course KiCad produces the printed circuit board design, which then has to be converted to CNC code.
Right.
And the CNC code has to go through a controller in order to drive the CNC machine itself.
Right, and that's where Chili Pepper is nice for that part.
Yeah.
So I would definitely recommend that. Look into it.
Okay. So it works out well. I'm happy with the fact that I have small tools that I can afford to buy and keep right in my workshop and use pretty much whenever I want. I rarely have trouble getting up to speed on them again. So the same thing with my 3D printer.
There's Doug.
I do not have a laser cutter. I have friends with laser cutters. That's good enough.
Well, they're going to be relatively cheap. You can get, well, a small one for about $100 or at Micro Center.
Oh, really?
Yeah, in fact, something like this.
Yeah, I'll have to look for something equivalent. This is only my second meeting, so I'm in Canada, so I'll have to look for a
So
Canadian.
it does basically about 8 by 10 ish, and it's a 1.5 watts. And you can see it's very compact and portable.
Now, you said 1.5 watts, John?
Yeah.
So what can you do with a laser of that rating?
Mark, etch is mainly what I got it for. So you can mark on leather and stuff like that.
Okay.
But, in a moment I'll go get something etch on leather to give you an idea of what it looks like.
Yeah, I actually went down to Micro Center to get one of those, and they sold out just before I got there. I was going to use it for a plasma torch holder.
Yes.
For small
I've
parts.
seen that.
Bigger versions, but besides that, but the price point ratio is good. So,
Yeah. So, Tom, this is kind of a really interesting period when it comes to hobby lasers, because they're stacking laser diodes now. Like that one's 1.5 watts, but I've seen them go up at least as high as 40 watts. All right, now at 40 watts, those lasers are very effective on wood and stuff like that. They can do opaque acrylic, but they can't do clear acrylic because of the wavelength. Okay, but like John said, they're very light. They're reasonably affordable. A K40 is by the time you get finished setting up a K40, they're probably about the same price as the higher diodes, higher rated diodes. Okay. Now, I decided to go back with the CO2 laser for myself, but it is an interesting, because at one time, if you wanted to cut, that was all you could get. Now with the laser, with the stacked diode machines, there's another option, and you have to be careful, because when you look at what they can cut, they'll say they can cut this, but what they don't tell you is it took them 12 times. They had to run 12 passes to cut it, where on the CO2 laser, you cut it in the first pass. So but the CO2 laser, I've been screwing around since I burned mine up. I've been screwing around trying to get it back up, and I'm pretty experienced on it. So, I've had it running, so I'm not saying I haven't, but now I'm trying to improve it. So it's really, I would love to see somebody report on their experience. Well, I think now that I'm talking about Harold, what is that? What is your rating? Is yours about 10 or 15? What is your rating on yours?
they can get up to, now they're up to 40.
I'm an 11. Yo, what's where's all the women? I'm rating for what?
For your laser.
Your diode laser.
It's 10 watts.
Okay. What can you cut with that?
I can, right now, if I look at I'm looking at basswood, and I got 4 passes. I can cut that. I know you can't, because I tried really hard. Can't cut the rubber stamp, the real thick rubber stamp material. It's just, it's just not going to do it.
Yeah.
But I think I'm supposed to be able to cut dark acrylic.
Yeah.
I'm supposed to be able to etch metal. And I read some crazy thing somewhere that somebody swears they could cut really, really, really thin metal. I'm like, what, tin foil? You know, but I can cut most woods. And I'm supposed to be able to go up to about 20 millimeters with multiple passes. And I've seen people online with doing 15 passes cutting hardwood with the thing. But it's 15 passes. I mean, literally, you can see how deep it goes every time it goes down the thing.
Yeah, but that's a 10 watt. That's a 10 watt.
It's a 10
Right.
Yeah.
Supposedly you can do about 10 millimeters with the 10 watt, but they're now getting 20 watts and 40 watts out there.
Yeah.
So, and
But the price
watts,
goes up,
When,
significantly.
at the 20 watts, you can in theory get color in the mill. So by heating it up certain temperature, you'll get a range of color on the mill.
Yeah, I've seen that. It looks really cool. I have yet to try it though, but
Well, ideally you want a 20 watt for that feature. I don't know if this will show, but I'll see if it does. But here's an example of image I laser on the leather.
Oh yeah.
Yeah, that's
So
good.
that's why I mainly got it for was bark and edge and type stuff.
I was looking at that today. If I wanted to go from 10 watts to 20 watts on my laser, I mean they've got kits for upgrading and stuff
you
like
can
that.
change out the module.
But the module is more expensive than what I paid for the entire laser kit. Just the module itself to do that. So
Well, it depends on the brand, but
yeah.
I have two friends who have laser cutters, and one's at 20 watts and one's at 30 watts, I think. They're using them to cut thin plywood and balsa wood. They're model airplane builders and general woodworkers.
Yeah.
They will often cut in 2 or 3 passes or more, mainly because they worry about charring on the edges of the wood.
right.
They try to be a little cautious about that.
And that's where they have air assist supposedly to help on that.
the air assist and also some of this stuff. This is transfer paper. And what you do is, or masking tape a lot of times. Masking tape tends to leave junk on it. This is supposed to be clean as it comes off. Used it a couple times and it seems to work. But the charring chars the paper and you just peel the paper off. The wood stuff comes off clean. That's the idea.
Yeah, but I think what Tom is talking about is the side of the cut. Yeah, and
You're gonna
that's
get that.
yeah.
I don't know how you don't get that with a laser.
Well, I've actually seen where they can get it kind of brown if they really tune it up for a specific process. But I'll be quite honest, usually I found a few tricks. I found the stuff that you use to wash your hands when you work on an automobile?
Oh, that orange stuff?
Yeah, that's it. Like Gojo, but not a little more liquidy than Gojo. You can take that, put it on an old toothbrush and wash it along the edges of it. And when you get finished with it, if you do it right, you can get rid of anything that would transfer. Okay. If you're cutting acrylic, the trick is to get yourself some Dawn. And you put a couple of drops of Dawn and just smear it over the top. So the top of your acrylic is all soapy. Okay, it's got a thin layer of soap on it. And that acts the same as the transfer paper that Harold was mentioning. And the nice thing about that is that it doesn't seem to impede the cutting at all, where if you have paper on both sides. The real problem is if you're doing something really intricate, with lots of cuts and stuff and little small pieces, peeling off that tape where it's been cut, little spots of the tape can be kind of painful. It does a good job of protecting, but it's sometimes hard to clean off, even if it doesn't leave a residue. But
I've seen people mention that Dawn trick before. I have yet to try any of that stuff.
It works great, Harold. Now I don't know about laser diodes, but I will say this. the number one thing you can do, it suppresses fire too, is get air assist. Air assist is the number one thing you should have on your laser.
I do. I do have that.
Yeah, that's absolutely critical.
Not to subject the thing, but I ruined about half my first real project was a keychain with a front and back side to it, and I ruined about half of them because all that smoke and all the stuff that I've been cutting up got into my wheels and started squirt, 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 squirt. and then it did it enough. It got hard enough where the machine threw an error because it thought it was somebody had moved it or something, and it caused a problem. So yeah, that's a problem. So I had to take it all apart on Sunday. Not all apart, but enough, and got some stuff. Got some of that garage door thing and squirted in there, and it was perfect then. We'll see how long it lasts.
So there's another thing, Harold. I don't know if this would apply to this case, but it has on people that have been building CNCs. Open Builds. Open Builds, the website.
Mm-hmm.
They sell all sorts of little wheels like that and everything. Well, they have a premium kind of looks clearish wheel. They're like $5 a pop, so they're totally different. And they have been very, very highly rated for that skipping type of problem. So
some kind of high-end polyurethane or something like that.
I don't know. I don't know what it's made of. I just know that people have been reporting that it performs, much, much better than the black wheels. Yeah. So something to think about. Anyway, let's see.
Thank you. I'll make note of that.
Yeah, make sure it's the right size, obviously. Yeah. So, yeah. Oh, I did have one other thing that I wanted to show you guys. If you'll pin me so you can see it, I'll show you what I was working on before I was working on this laser thing. Is you can see this. You see the CNC sitting in a small enclosure over there. Can you see it from over there? I don't know if you guys can see it.
Yes.
Yeah. Anyway, so that was what I was building last week, and I wasn't trying to abate noise. I was only trying to get it so that it would keep the silver dust from being all over everything, and because it is messy. So I've got if you could see it, I have my quietest vacuum, which is about 70 dB. So that's like small small jet engine with turbo boosting, but it's a lot lower than my other one, which is some 80 something. And you can actually run it in here, and that little container that sits around the spindle that sucks up, that I showed about 3 or 4 weeks ago, it actually is not a bad solution. Keeps it down to a minimum. Means that I don't have to go out in the hot garage and do it. That's a biggie.
Yes, if I were to use my desktop CNC very much more, I would need to go find a very quiet vacuum because the one I have is pretty noisy.
Yeah. This one, I just looked into it. It was one that I think it was my dad's, and he bought it through his company. So he had more money. He could go. He didn't have to go down and buy the cheapest one like me. He went out and bought a good one. And it actually is pretty quiet. So I'm getting I get this laser stage done, and then 2 months, guys. 2 months. Then we meet out at the Edwards and do the run. It's on. And I've already contacted my artist to finish up the rendering on the idea for mug. So the mug should be able to display it. We'll put it on the website here in the next week or two. And so cool, you know.
So what date? What do you say it's going
It's
to be?
November 18th.
November. Okay.
Yeah. And if you remember, it's one of those things that since we don't want to give out their parcel of land's location, you know, when we get close, when you're interested in going, you just email me and send you the address. And Tom, you and Pat, if you want to, you can watch remotely. We'll probably set up a meeting during that.
I'd like that.
And so you should be able to see it. Oh, wait a minute, Kareem, where is this? Oh, I guess he was putting it on. Yeah. So Kareem, okay, gotcha. Thank you. All right, who's next? There was somebody after me.
I think it was me.
Okay, yeah, Tom.
I don't know, just a quick insert. I don't know if you were watching my window while you were just talking, but RoboDog just rolled forwards and backwards.
Are you trying to say me you're fishing for a gold star there?
I'm fishing for a star.
Well, you have to show us now. Before.
I didn't want to interrupt, but
Okay, Tom, this is important. This is an actual rolling robot. We always go for those. I don't know. It doesn't look like it's moving to me. Oh, there it goes. Okay. Can you?
Doug, what are the cylinders above the wheels for?
the cylinders above the wheels are the legs. The wheels are attached to those legs. The legs will, they're in the down position right now. They fold up in order to put it on my back.
Oh, okay.
Doug, do you have a PID going on the wheels to go straight? Because it looked like it was rolling pretty straight.
It's probably by accident right now. The next step will be to, I have the PIDs being captured. I don't have them being utilized yet. So I'll be utilizing that as the next step.
Doug, could you do that one more time while we pin it to the video?
Oh, okay. I didn't mean to steal somebody else's thunder. I know somebody else was. Get this,
Tom, this is indoctrination, basically. So we
get this back just a little bit again. The object avoidance is not currently working because I've disabled the SR04. So it actually gets real close to running into that. Try right and left.
Oh, it's getting fancy. I saw a turn.
Not working quite well. I hear some tires scraping. Something must not be quite hooked up right. But making progress. We're back to functional again.
Okay, cool.
Give me a star and on to, I think Tim was up.
Tom.
Okay.
I'm going to open up a presentation here, if I may.
Okay, wait a minute. Let us pin you. Everybody got it? Is Tom pinned?
Let me just,
Oh, wait, you're going to share it, right? Okay, that's good.
Yeah, let's have a look at the window. This looks like it. Share. Can you see that?
Yep.
Okay. I'm assuming, let me just see here. There we is. It looks quite grayed out. Is that normal? I haven't used Teams before. I normally use Zoom.
It looks good to me.
Yeah, it looks
okay.
good. We see the bright yellow and the red.
Okay, now if I can just see it myself.
You probably shared a window instead of your whole screen.
I shared a window, yes.
Yeah, if you share your whole screen, then you get to see what we're seeing. Been my experience.
Okay. Let me just, got it. Okay. It was giving me a message of some kind. I belong to several other robotics clubs in the last several years. It's kind of been a replacement for what I used to do, which was model airplanes, which is becoming increasingly difficult to do in Canada as regulations tighten down a lot here on model airplane flying. So I am probably not as advanced as many of you are. I still tinker a lot, and I still tend to use a lot of the stuff I have lying around in my workshop. This particular project, which I've just gotten to a useful benchmark point, was to add quadrature encoders to this little robot body that you can see in the picture. This toy is a where is it written here somewhere? A Snap Rover robot chassis from a company called Ellen Co. Useful scientific toy. Picked it up at a garage sale somewhere. I pick up a lot of my things in garage sales or surplus stores. The intent is to ensure that I can put together a robot that knows where it is, as you can see in the quote from one of the MIT primers on odometry. I'm not prepared to get into things like LIDAR and radar yet, so we're still looking at very simple ways of figuring out where a robot is going. One of the things I learned in the course of this little exercise was I'm an electrical engineer and an automation engineer. I'm not a mechanical engineer, and I'm all thumbs when it comes to making things that need precision. So one message that I keep teaching myself over and over again is to be very, very precise. And that's very much true with this particular exercise. So the attempt is to add quad encoders to this device, which has four-wheel drive using a gearbox on each side of the chassis and one motor to run each of the gearboxes. So I wanted to add quad encoders on both sides. Now, if I'm lucky here, I can figure out how to advance the page. Not that way, obviously. Let's try this. Did the page advance?
Yes, it did.
Okay, I'll keep looking at the bigger picture here. A little bit of some design notes. First of all, the picture on the upper right-hand side shows one of the gearboxes exposed. The gearbox cover is removed. You can see the 6 or 7 gears that are involved. The intent is to add optical sensors to the center upper gear, which conveniently has 6 holes drilled in it in the center, and to have the optical sensors, 2 of them, shine through those holes with a 90-degree phase shift or 90-degree plus n times 360 in order to get reasonable quadrature indicators. I like to pick stuff out of my junk box instead of buying things. So in my sensors junk box, I had 4 sets of emitters and photodiodes taken, I think, from really old 8-inch floppy disk drives. I've put the specs up for these things. For those of you familiar with what IR emitters and photodiode specs look like, these are very old designs. They're not particularly sensitive. They take a lot of current to emit IR. So I set this stuff up on a whiteboard so I could test it out and get it working reasonably well. And determined that the 15 millimeter spacing that I wanted to use, which was a comfortable distance for mounting inside the gearbox, would work fine with appropriate LED currents and load resistors. I initially started with a 10K load resistor on the photodiode, but the photodiode is not very sensitive, and 10K only got me about 2 volts of variation with perfect alignment. So that wasn't a good choice. So I went up to 22K, not wanting to go too high because this is sitting very close to the motors, and I'm worried about the noise induction in the wiring coming off the photodiode. So 22K seemed to work okay. Mechanically, I mounted the photodiodes in holes that I drilled in the back of the gearbox chassis, the yellow plastic parts. And the faces of those photodiodes stuck into the gearbox. It was a very, very nice idea. It worked well. The emitters and photodiodes are mounted in TL18 metal transistor cases. And those are very easy to mount and relatively easy to work with. The The LEDs are mounted on a perf board. You can see their mounting in the lower right-hand picture. The perf board is cut to fit, along with small bolts and spacers to hold it, into a well that's in the gearbox outer cover, just in front of the middle gear that's got the holes in it. This all looked like a fabulous idea. So I assembled all the bits and pieces for both sides, and I assembled one side, intending to get to the point where I could begin to test it. And that's when the fun starts. First of all, the 15 millimeter gap, which worked really well on the bench, does not work when you mount this thing inside the gearbox. I don't get enough intensity to produce a reasonable voltage variation on the receiver. So I reduced it down to 11 millimeters, and that worked okay by moving the LEDs closer to the gear. So the ends of the LEDs, which have a little lens on them, are probably a millimeter away from the face of the gear. Hopefully they'll never hit the gear. So far they have not. But that tended to get me some pretty good signals out of the photodiodes. My mechanical precise measurements that I mentioned earlier ended up having the LED in the receiver of one pair significantly misaligned, had the same pair off to one side so its path was partially obscured by the gear face, and despite every careful measurement and double check that I did, produced pulses 180 degrees apart. And for those of you that know how quad encoders work, that's not going to work. I couldn't move the receivers because they're mounted in through holes through the gearbox back wall, but I was able to recut the perf board. In order to move it higher, I was able to remount one of the LEDs in order to get better positioning of the IR beams. It took me several tries to get this thing to the point where I was back to getting reasonably good-looking full amplitude waveforms, and that they looked like they were getting close enough to 90 degrees to be useful. Pardon me. Then I put stuff. I put the gearbox onto. I have a small DC motor tester that I put together several months ago to automate the testing of small motors. So I used that to run this thing. And now I can put the waveforms on my scope and have a look at what they're doing. I'll show you with the scope pictures in a minute. But the pulses turn out to have very slow rise and fall times. So slow that this is going to be very problematic in any application. So I added comparators to all four of the receiver signals. These were simply LM324 op amps. That's a nice quad package to work with. Very stable, not terribly fast, but plenty fast enough for this. I added enough feedback to ensure that I could get several hundred millivolts of hysteresis. And I initially put one potentiometer to provide a switching voltage reference to all four of them. Eventually had to add a second one. Now I'm getting nice square pulses, and I felt that was not going to produce any problems when I feed these into a microcomputer's input. However, once I started to look closely at them, I'll come back to that in a minute. Once I started to look closely at them, I discovered that the pulses had varying duty cycles depending which of the 6 pulses that make up one revolution you were looking at. And the duty cycle variation was quite high once you start to measure it in detail. So after a lot of messing about, I added precision paper patterns on top of the face of the gear with the holes in order to ensure that the gap widths are all identical. I also ended up having to add a separate reference voltage so that the 2 comparators used for the 2 op amps could have independently set reference voltages for purposes of the comparator switching. And finally, I'm not sure if it shows here, just a few days ago, after getting everything working on the first gearbox, I added everything onto the second gearbox and tested it and made many of the same changes to the second gearbox plus a few others. Again, back to my inability to either do precise measurements or drill precise holes. I'll have to work on that, I think. A few pictures of what this stuff looks like. The large picture on the left bottom simply shows the inside of the chassis of this robot, where I've added some of the stuff. The comparator printed circuit board is on the right side. You can see some of the lower gearbox with its cover in place. The upper gearbox has had its cover removed. In the center of the picture, you can see the small circuit boards that hold the infrared photodiodes on each side that stick through holes in the yellow plastic. Directly below them, there's the two motors, which are used to drive the gearboxes. As you can see, there's potentially a fair amount of electrical noise in this environment. So I was worried a little bit about the photodiodes and the impedance of their output. It seemed to work out okay. The pictures on the right, the upper one is a bit of a close-up showing the mounting of the perf board that holds the infrared LEDs sitting in the center of the gearbox. This one is properly positioned. It's fairly close to the center gear with the holes in it. The lower picture shows where I have had to add the paper pattern in order to ensure that the waveforms from blocking and letting pass the photo beams were going to be as close to a 50% duty cycle as I could get them. The white pattern is partly black and partly white. That has nothing to do with the application here. It just happened to be that I found somebody's very nice patterns online and was able to measure them and cut them out. And his pattern printed black and white on my laser printer. That approach has worked out fairly well. Some of the waveforms from some of the results here. Whoops, sorry. These waveforms are simply pictures taken from my my Handtech scope, which I love. I think it's a fabulous scope for my purposes. Upper left shows what the waveforms typically looked like after I got full amplitude. In other words, I have all the mechanical issues dealt with mostly, but have not added comparators. So you can see that the rise and fall times on these on this infrared photodiode are really bad. And you can also begin to get a feeling for the fact that there's some problems here with duty cycle. But I also had to square this stuff up. So the picture on the right at the top, I've added the comparators. It became a lot easier to determine I had bad duty cycles. I'm not at 90% offset for quadrature encoding, but I'm no longer at 180 anymore either. So I'm close enough that if I fix the duty cycle problem, I can get this thing to perform reliably as a quad encoder. The bottom left picture shows what the waveforms looked like after I added the paper patterns. This is before the comparator because I wanted to see what was happening with the analog waveforms out of the photodiodes. Things are beginning to look a lot better. The upper graph is the same in all of these cases. The lower graph in the bottom two pictures is simply an expansion of the upper waveform. The scope makes it very easy to do that. And finally, the lower right picture shows the end result with squared up, properly duty cycle oriented patterns for all 6 pulses around 1 revolution of the gear, which are sufficient to get reliable quad encoding out of it. This is all done on the first gearbox that I worked with. I've completed the second gearbox. That simply confirms that I was able to get the same results on the second gearbox. Any questions?
Well, I guess first thing, Tom, is you run it through a series of different speeds because you're really on the hairy.
Yeah, exactly.
So
yes, I did that.
Yeah, so because I wouldn't expect that as close as you are, that at some speed you'd lose it. Yeah. And you know,
I'm worried about that as well, Doug. But yeah. So that's the nice thing about having my little automated motor tester. Is I can set this thing to run at a variety of speeds, and I have done that. I just haven't shown the charts here.
Okay. And the other thing, though, you know, what you see up with no comparators is pretty explainable for an IR diode, because they, you know, as the part of the wheel passes from it, it's not going to be sharp. It's going to be, in fact, what I'm more interested in is why you've got the flat spots at the top. I would have expected it to be more sinusoidal. I can say this, I think, sinusoidal.
Good point, Doug. Yes, I hadn't thought of it.
I would have expected that. But, I mean, you got it working. Now, are you aware, if you wanted to go this way, when I'm trying to guide somebody, first of all, the first thing I would tell you is try to do it with a magnetic and Hall effect sensors on the back of the shaft of the motor. That's what you really want.
I agree.
Yeah, and then the next thing I would say, if you can let me share something real quick, can you unshare and I'll share back and give it back to you?
Got it.
Okay. Let's see. Come on, what? Oh. Okay. All right. If you look at, see if I can get it here. These right here, these little IR obstacle avoidance sensors, they're very, very flexible. I've used these for all types of IR gates. They have a built-in comparator on them.
Like that.
Yeah, I want to say they have I'll see if they'll show you a picture of one. So that's your comparator right there. This little guy.
Yep.
There, and they have a couple LEDs. You can take the sensors out and, wire them and spread them to get your distances. They do have some that have a 4-pin, which also brings out the analog signal as well as the digital.
Yeah, I have the 4-pin version here.
Yeah, those are the best if you can get them, but they're a little harder to find. Anyway, that's if you weren't aware of these, I'd say you can see that this one's going to sell you how many? Whole bunch for $6. They're really cheap. You can't even buy the comparators for that, So anyway, let me unshare this. Okay, you can have it back.
I agree with you. This is my self-balancing robot.
Yeah.
And I don't know if you can see it here or not.
Yeah.
I got to show you the other side. Without getting it out of focus too badly. Oh, you want to see this side. What you'll see in there, you'll see the wheel with the pattern on it. Mm-hmm. And that I've removed the IR sender and receiver from that board, and I've mounted it right up tight against that pattern. And then the electronics are mounted on the bottom platform of the robot.
Yeah.
I was able to get this to work, but it was very difficult to get to work because the tolerance on the mounting distance is really critical on these things. And the second problem I had with them, and if you can see this, see if I can show that. Can you see the second potential?
Pull it back. It's a little out of focus. I can't put.
How's that? Better? What you'll see is there's a second potentiometer that I've glued on top of the first one because that initial potentiometer is so difficult to adjust. I had to add some refinement to the adjustment for the threshold voltage on the comparator in order to get them to work at all.
Okay. Now,
so that made a big difference.
Okay. Now, on that case, you saw you have the TT motor. That's the TT metal. It turns out that if you can get from DF Robot for I think it's $8 a replacement for that has a built-in encoder on the end of the shaft.
I've seen it, yes.
And so that's the way I would recommend to go on that. I've used TT motors a lot, but I usually use them for teaching people. I hate them.
They're not a good motor. They're just cheap.
Yeah. So anyway.
But I have a bunch of them in a box, and I thought I better use them for something.
Yeah.
I got it to balance. It doesn't balance well, but it balances.
Mm-hmm. Yeah. Well, that's cool. That's a big. That's a real accomplishment. We've had several people. We have David Anderson. I don't know if you know him, but he has a wonderful balancing robot. I mean, way out of league of anything that I've ever seen before. But other people have tried to make balancing robots with limited success. So just getting it to balance is good.
In one of the other groups I belong to, it's been a 50-50 success ratio for those who have tried. Most don't try, but 50 to 50 is about what happens.
Yeah. Yeah.
I find that applying conventional PID loop stability criteria to the regulators that are in the balancing robot is very difficult to do, and you simply keep attempting by trial and error to set the constants in the PID loop. Mm-hmm. Other units where I've implemented PID regulators have been far easier to apply a formal method for tuning, but not the balancing robot. It was very difficult.
Yeah.
I have no idea what you're talking about.
Yeah, Harold's been messing with balancing robots for a while.
And none of them work, so.
Okay.
Well, they have not worked long enough so I could call them ever to balance, even though they did stand up sort of until they augured in.
Yeah.
So.
Well, there's one person in the Vancouver club that I belong to who has an amazingly good balancing robot. And now he's used stepper motors as his prime mover, and that appears to make for a much easier to set up mechanism. He also used bigger wheels than I used. I think my wheels are too small.
Mm-hmm. Yeah. Yeah, if you search for David Anderson, balancing robot, you might get a video of one of his. He's got videos in our archives that you can look at. Like I said, it's incredible. And then it's actually his second version because he learned that you don't store lithium batteries inside of your trunk. So,
well, I've as I say, I've used these little optical transducer devices.
Yeah.
And I've had some good luck with them. I've also had some bad luck with them because they're very, very difficult to get the gap distance right.
Mm-hmm. They make great drop sensors and stuff like that. Okay. So, yeah. Oh, okay. Who else? Paul, you haven't been in on them for a while. You got anything you want to say?
Nope, sorry.
No. You going to be able to get mower out for Robo Columbus? Even for a demo?
I don't think so. I've got too many other projects going on centered on the RV. But I do have a story that you guys might enjoy.
Okay.
I was helping my neighbor with a project that can only be described as Rube Goldberg. So I'll tell you the Rube Goldberg scheme. He's got a robo-mower that no longer doesn't mow when it rains. It mows regardless of whether it's raining or not. So he wants to make it not mow when it rains. And his desired approach for that is to remove power from the exciter that runs the wire that runs around his property. Okay, so what he decided to do was get one of those little moisture sensors that consist of a little circuit board, with like traces interleaved and wired off to a little board with a comparator on it, and then I helped him wire that up to a circuit that drove a MOSFET, which passed current when there was moisture, passed current through an electromagnet, and then his intent is to hook the electromagnet up to a ring door egress sensor, and then so the ring door sensor would then send a message up to the cloud, and he'd use if then that to send a message back down to a smart switch and turn the switch on and off too. I think that's the biggest piece of hackery that I've seen in quite a while.
But Paul, how often does he cut the grass?
Well, it runs pretty much most of the time.
Oh, okay.
But, it just doesn't want it to run when it's raining.
Yeah.
So,
I would have thought you could just look out the window, and if it's not raining, turn on the lawnmower.
oh, well, yeah, but that would be the easy way, right? I think what's very commendable about this approach is it uses the cloud.
I like that.
Anyway, that's all I got.
So, and you were responsible, Paul, to help them do this?
But he was a system designer, and I bow to the system designer.
Yeah. Oh man.
So 7 Photons had something.
Yes. That's Jack.
Yeah.
Where's Jack?
So, here. Can you all hear me?
Yeah.
All right. So, I thought you'd all be interested to hear for my final semester group project. We're working with Raytheon to do this drone competition. And but it's kind of interesting because we'll have these little robots that we'll be programming, and then each team that we're competing against will also have a robot. And what we're going to do then is we've also got a drone. It's going to have to go around and dump water on all of the other little robots except our own.
Ooh.
I thought you'd all find that.
That's harsh.
I'm sorry?
That's harsh.
Yeah. Before they used to just shoot a laser at it, but the Raytheon didn't like that, so they want us to drop water on them now.
Well, that sounds like it has a real application in the forest fire fighting domain.
Yeah. Mm-hmm.
So
it's going to drop water balloons. Water.
I'm sorry?
Will it drop water balloons or water?
That's up to us. We're thinking we're just going to have it fire like a water gun type of thing at it.
So is Jack? Is it to disable the robot with water? Is that the intent?
Yeah, we're going to have just to make it wet. We're going to have sensors on it, so the robot should be protected from being actually harmed by the water.
So no robots harmed in this competition.
Shouldn't be anyway.
Okay, gotcha. Okay, so
Excellent. I like it.
Yeah, it should be fun. It's kind of nice because
if it's got a Ukrainian application. I don't know.
It's kind of nice because we aren't starting off from scratch. We do have previous teams. However, the other previous teams didn't seem to document the code that much, so we're trying to learn that from scratch a little bit.
what is the hardware?
So there's a Ardu pilot. Have you ever heard of that?
Yeah.
Okay, that, and then this NVIDIA microcontroller. It seems like a really high-powered Raspberry Pi made by NVIDIA.
Okay, like a Jetson?
Yeah, that's exactly what it is.
Okay, so a Jetson and Hardy Pilot. Hardy Pilot. Guys, is that the one that's distance camera? Is it a distance camera or is it just? Go ahead.
It's basically just a microcontroller for controlling drones.
Oh, Hardy Pilot. Oh, I know what you're talking. Like a Pickhawks. Okay.
I haven't heard of that one, but
okay. Well, so is Audi Pilot? Is it a little black box?
Yeah, a little black box with a little tiny orange rectangle on top.
Okay, is it a 2.6?
I don't remember that.
The reason why I'm wondering is because those were based on
ST411.
They were based on a Mega.
Okay, it
They were
doesn't
based
look
on a
like
Mega.
it.
Huh?
It doesn't look like it's the 2.6. Let me see if I can find.
Because I mean that's really obsolete, is what I'm saying. I'd be surprised.
Yeah, it doesn't
I think they
look like it's.
updated and gone away from the Arduino.
Yeah, I know. They went to Pickhawks and then they changed. That's when I thought the RD pilot name disappeared, but I may be wrong. Maybe they kept that.
Yeah. See if I can find what version it is.
More picture of it. That'd be cool.
Yeah, I'll find that as well.
Yeah.
And so just to be clear, it's a drone that's flying above some other robots and dropping water on the ground-based robots?
Yeah, exactly.
Sounds like it might have something to do with your neighbor, Paul, with the when it rains, it stops, right?
Yeah. So you're using Mission Planner?
Yeah, I'm pretty sure.
Yeah.
Haven't gotten to look at that part yet, but.
Yeah, that's a real nice system. I played with it with the older versions and tried to get it to work a couple of times. And I was able to go around the course and hit every waypoint. But but that was my high point. After that, I kind of like went and developed myself out of it. Could never get back there. You know, but yeah, that's a really nice system.
Mm-hmm. All right, let's see.
So what's the goal of the contest? To be the first one to wet all the other robots in the ground before they you get wet or something?
Well, I think it's so we're timed. I think it's a little bit like how we do the 6-can competition. All the drones aren't flying at once, if that was part of the question.
Oh, okay.
And then so there's 4 different levels. I think the first one is none of the robots move, and they're placed on the field, and you try to get them. Whoever does it the quickest and gets the most of them wins. And then the other one is where they're moving in a straight line. And then the second one is where the robots move in a straight line, but then at some point they turn a little bit and then continue in a straight line. And then the final one, or no, not the final one. Then the next one is where they move in a straight line. Then at certain points they turn and cross into a different area, or different lanes basically. And then the final one is they just run around randomly.
What mechanism does the drone use to try and identify where a ground-based robot is?
Yeah, so that we've got a 3-dimensional camera. I don't remember. Yeah, I think they're called Z cameras. Is that the right word? And then, yeah, that's basically all we're going to be using. And there's a little QR code type of thing. I can't remember the technical word for it. RQ mark.
Tag?
I'm sorry?
April tag, maybe?
An RQ marker. Not sure if I'm pronouncing that right. That's going to be on top of all of the robots.
Yeah, sounds like same idea as an April tag.
Okay.
Yeah.
Interesting. So they aren't telling me what the exact model is.
So I was just looking up RD Pilot, and it's the software is the RD Pilot, and there's lots of different hardware implementations. One of which is a Pixhawk.
Yeah. Okay. So they kept the name RD Pilot for the software.
I think we're still using an RD Pilot board, since I thought I saw RD Pilot written on the board, but I don't know. It's not. Yeah, I don't know.
Yeah, that's kind of weird. Like I say.
Oh, here it is. What is this thing? Oh, I think you might be right. Cube Pilot, I think, is what it is. Let's see.
What?
think it might be a cube pilot.
Okay.
Let's see if that's the right running RD pilot. Okay. Yeah, that's what it is.
Okay.
Interesting.
Oh wow. So you don't really control or are responsible for the robots per se. Only that you own one of them. The real task is in the drone.
That's the real task, but we do have to make and program the other robot as well.
To do the 5 stages?
Yeah, but that's the easier part.
Yeah.
Mm-hmm.
Okay, cool. I see.
Mm-hmm.
Yeah, it'd be interesting to see. That could be, working in 3D is always going to be really complex compared to 2D.
Mm-hmm.
Yeah. Because, if you bounce it on the ground, it doesn't help. Probably your drone gets kind of smashed.
Mm-hmm. Well, I'll keep you guys up to date on how that's going.
Okay. How long do you have?
So it actually is going to spread across 2 semesters. However, I'm only going to be able to work on it for 1 semester. It's the unfortunate thing about it, but.
Okay.
Mm-hmm.
Or it could be a good thing. It could be.
That's true.
Yeah. There are many people who have made a career of leaving a project right before it crashed and burned.
Oh dear.
Yes, done that once or twice.
Gotta know when to leave.
Yeah.
Mm-hmm.
So, have you lined up a post-grad career opportunity yet?
No, not yet. I was going to start applying. I tried applying a little before this, but didn't seem to be the right time to be applying, so the beginning of next month I was going to start applying again. That seems like that would be more optimal.
Okay, cool. Well, good luck on that.
Oh, thank you.
Yeah.
Mm-hmm.
Getting that first one's always a bummer, but once you get that, and you get some experience under, because you'll read all these job descriptions that say, well, walks on water, can multiply loaves of bread and has 15 years of experience.
Mm-hmm.
It turns out that after you've done something, you can kind of get in that group.
Mm-hmm.
My favorite's always the folks looking for 10 years of experience of a thing that came out 6 months ago.
Yeah, that's a good one, Harold.
We all laugh because we've all seen it, right?
Yeah.
Mm-hmm.
Okay. Anybody else got anything to chip in?
I'll just ask if the presentation style I was using is.
Oh, it's very helpful.
Works for this group.
Oh yeah, it works well.
Okay.
It really gets the ideas across. It's well, at least for me, it's what I'm used to seeing. So I'm, but usually we don't. You don't have to do that, Tom, to talk. Okay. I mean, if you got time to do that, or if you're working and documenting your project as you went along.
Doug, that's actually it. Is I make some notes just so I'll remember in 6 months what I did.
Yeah. So. Hey Ray, how's your outdoor robot going?
Oh, it's pretty good. It's still in the state it was from last year, so
okay.
I've got to.
But it hasn't degraded yet.
No, still working. I'm gonna put another battery in series so I can get up to the working voltage of the motor, and so it should go. I only had it like at 1/4 speed. I know you made a comment like, okay, this thing is slow.
Yeah.
So that should hopefully take care of that. It should run much faster. So
Yeah. Are you going to work on that back? You got lucky a couple of times with that caster. It was pretty minimal. You know?
yeah, it's pretty small.
Yeah. So
Yeah. I've got. Well, I still have the other 4-wheel drive platform. So.
Oh, okay. I've been thinking about that too, Ray. You know, my Jeep, the one we were talking about the other day. It might be fun, you know, if I could. The only problem is, like I say, is if something breaks on that type of toy,
Yep.
you're screwed. It's gone.
Yeah, you can't do anything with it after
can't
that.
do anything with it.
Spare parts or something.
Yeah.
Anyway, so I think I'll have enough time. My wife and I just came back from a trip. We went to circumnavigated France for almost 4 weeks. So
Sounds like fun.
yeah,
Oh, cool.
That is a cool trip.
yeah.
How'd that go?
It went really well. We rented a Class B camper van. And
cool.
they have these locations, literally hundreds of them, all over the country. They're called AIRS, AIRES, and some of them are free. The most expensive one was $25 a night, or €25 a night, and it's a place where you can park your RV, and because a lot of the towns are not set up for RVs. They have one of the things we found out. They didn't explain that to us when we rented the thing. The height of this camper van was 3.1 meters. Some of the parking areas are like 2.1 meters, or you'll have a bridge that you can't get under because you'll go convertible. You'll cut the top off your RV. So, and it's like using Google. It doesn't know where those things are, and it will. We tried to get to this one AIRS in. God, I can't remember the name of the town now. Anyway, it kept rounding us through this one overpass that wasn't tall enough. We couldn't get through it. So it's like we approached it. Luckily, there was enough room to stop and turn around before we were kind of, stuck in traffic or had a line of cars behind us that, we would have to have backup so we could get out of the thing. And we actually found some, it was truck GPS software that would only show you the routes that a truck of a certain height could go through. And so that put us on, a lot of the major highways and toll roads. But, if you see a taller truck in front of you sailing by, it's like, okay, he's either a test case or this is a clear road. So, but it was a lot of fun. Only saw a few people with the horizontally striped, blue and white shirts. Saw very few berets and no mimes at all. I don't know, maybe we just weren't where the mimes were, but no mimes. So.
Did you get a chance to see the Palais Garnier?
Nope, don't think so. Where's that?
All right. It was in Paris.
Oh, in Paris. Okay. Yeah. Yeah, we went to the Musée d'Orsay and the Louvre. It was the Louvre is like a 3-dimensional maze. Not all floors go through. So if you want to get from one side to the other, you have to go up like either 1 or 2 levels, go across, go over, go down.
Oh dear.
And it's huge. I mean, I guess a lot of people think of it, just for the Mona Lisa, but God, it's got, displays and artifacts from 7,000 BC, I think, and, on forward. And Yeah, just incredible to go through. But and that was the other thing. We looked at the weather forecast. It said, this time of year, in the northern part of France, it'd be like a low of 50 and a high of maybe 70. And when we got there, it was like, both temperatures were 15 degrees hotter. So, and a lot of homes in France don't have air conditioning, and the camper had cab air. So, when you're driving it, you could, keep cool. But around 5 o'clock, you didn't want to be near the thing because it was, no air conditioning. You could open windows. There were no forced air fans or anything. But so it got a little warm in the evening. So.
That's a Class B. That's the one that's kind of like a big van.
Yeah, like the Dodge ProMaster, the Ford Transit. Those are both Class Bs.
Okay.
Or they make Class B campers out of those.
Yeah. Okay.
This one was a Volkswagen. It was the Grand California is the model, and that's their Class B van. But yeah, it was a lot of fun. We we had like a catalog of things, the different towns that we wanted to go to. One town, it's in the Loire Valley. It's known for its foie gras, and they had statues of geese, kind of in this one area, and they actually force feed the geese so it fattens their liver to make better foie gras.
Wait, is that made out of geese? I thought it was made out of ducks.
It can be either goose, geese or duck, but
I think geese is traditional.
Yeah, but anyway, and then it also had a museum dedicated to truffles. So food is like everything there.
Well, that's like when in Paris, you go to England, and their museums are all over the place. A lot of history.
Yeah.
You go to France, and all of the museums are art museums.
Oh, a lot of them.
You know what I mean? You got the Modern Art Museum, you got the Louvre, you got, so-and-so Impressionistic Museum, but they're all art museums. They're not into the history thing as deeply as, say, the English are.
Yeah.
Yeah, anyway.
It was a lot of fun. It was kind of the,
took a lifetime.
My wife, she said we're not going to do any more type A vacations where, you get up, you drive 3 hours, you go tour a town, you walk 7 miles every day, and you repeat the next day, and But that's what this was. It was a type A vacation.
Yeah.
So,
yeah.
Oh, went to Chamonix. I don't know. Jack, do you know? Yeah. Yeah. Anyway, it's around Mount Blanc. Is in 4 different countries. I think I want to say it is the tallest peak in Eastern Europe or Western Europe.
Right.
Anyway, there's, you could take a gondola up to the top, and then you could take another one from the top of Mount Blanc to Hellbrunner Pass, which is actually in Italy. But, I don't know where the divide is, but it was like a 5-kilometer distance from the peak of Mount Blanc to, where the cable ended in Italy. So, anyway, so, I was thinking that it was going to be cold, or cool. And so I brought, all kinds of long pants, and, long underwear for the top of Mount Blanc. It turns out that, people were going up there in shorts,
I made the same mistake.
Yeah. Oh, say it again.
I made the same mistake.
Oh, you did? Yeah.
So hot.
Oh, yeah. Yeah. Brought 2 pair of shorts.
Did you all hike there?
We hiked a little bit around Mount Block.
Oh, okay.
I actually hurt my foot, and but I wasn't going to let that stop me. I was going to hike around Mount Blanc. So, yeah. So we did just a small. There's like all kinds of trails around. The mountain. It's not like you don't need technical mountain climbing gear, ropes and crampons and, all that kind of stuff. It's just, not necessarily a level hike. There's some areas that can have significant elevation gain, but the section that we walked on was, mostly flat, which wasn't mostly flat. So, but, so yeah. Well, if you guys are interested, I'll have to do a slideshow of, or
Yeah, I'd like to see it. Yeah.
It sounds like a cool trip.
Yeah.
Yep. Yeah. I think the next one though, it's going to be, like on a bus or on a ship, where
Yeah.
we don't have to do this, And she drove the whole way. She got really good at it. There is like very few traffic lights. They use roundabouts. So, you'll go through these towns and it's like, one roundabout after another, and so I was at the navigation. It's like, it looks like exit 3. Nope, it's exit 2, It's like, oh, and the GPS didn't always keep up. It's like you're going around the roundabout and there's a lag there. And it's like, oh no, this looks like, take this next exit.
Ray, how is your command of the French language?
Horrible. My wife had been studying French for some time. There's all kinds of apps that you can use. I think my method is to say, like, instead of the, stick a la in front of it, like la toilette, or and just point,
Well, living in Canada and having been theoretically trained in French at school, my French is good enough to read the back of a cereal box, and that's about it.
That's about it. Yeah. They talk a lot faster, and
I use my French every day.
Si vous parlez lentement, je peux vous comprendre. Means if you speak slower, I can understand you. One of the few things I learned in French.
Yeah, the first time that I went, I actually had this little phrase book, and it's kind of like lack of sleep and driving too much, and that kind of thing. Well, then we were encouraged to buy traveler's checks, and supposedly they accepted them, and we found a lot of places did not accept them. It's kind of like, it's we don't accept that. So. Anyway, so the thing was, figuring out, whether they did or not. So it was, acceptez-vous le chèques de voyage, I think, which is, checks of voyage or traveler's checks, So I confused that with fromage. So I was asking, do you accept the checks of cheese? So, got corrected pretty quickly. Anyway.
Checks de fromage.
Fromage, yeah. Not voyage. So.
Thank goodness for Google Translator.
Yeah. Didn't have it back then, but
Kareem, any update on Iron Rain? Oh, well.
Oh, no.
Oh, no.
So you're not going to be there then?
I've got a question.
Okay.
The VL53 L01 sensor or L1 sensors, the little time of flight infrared or time of flight sensors. Has anyone used those outdoors on a robot, like for the Robo Columbus?
What was the name of that again, Pat?
The little time of flight I2C sensors you can get. The VL53.
Oh, okay. VL51 something 3. Yeah.
3 L1 or L1 L0.
I don't know that they recommend using it outside. I don't know if it can handle the.
Yeah, I don't know, because I've got on my robot, I've got some ultrasonic sensors, but I know they don't work once once you have a little bit of wind, they tend to fall off pretty quick.
Yeah. I would think there are some sensors that Pololu sells that are about the same range in general that those sensors, and they may be the same family. I don't know, but that STI has expanded that family so much, so it's hard to tell. Like if you got the newest ones, just what they could do. But I want to say they even got up to 6 meters.
Yeah, they might.
Yeah.
I know. I tested the LiDAR light outside. That worked pretty good, and it was supposed to work up to like 40 meters.
Yeah.
And Doug, didn't you test the Benawaki?
Yeah, the Benawaki. I think it says it can go up to 12 meters. And what I found was it would tell you were within 12 meters. You know what I'm saying? But the accuracy kind of beyond 8 meters kind of went 8 to 12 was pretty bad, you know.
But even 8 meters, I mean, that's pretty good.
Yeah, I'm just looking for something for, a meter and a half, 2 meters away at the most. So 6 feet is plenty.
That's a real good question to pose to the group and see, because I've got some of those Pololu sensors. I'd love to see if they work outside. So maybe I'll take one of them out there and see, and let you know next week, Pat.
Yeah, I know I've got that time of flight camera that I've tested outside, and it seems to work fairly well in the daylight.
Mm-hmm.
Not looking directly at the sun, assuming the sun is higher up.
Yeah.
But trying to find it's got a 70-degree field of view. So it's got to be a fair bit in front of the robot before you catch it. Now a meter out, you're within the 70 degrees. It's that if something is closer, if you're coming up beside a wall or beside something, you're going to miss it.
Pat, can you link what in the description what that sensor is?
Sure, I'll put an Amazon link in.
Okay. There's so many time of flight sensors out now, I can't keep up with them all.
Yeah, I'm just.
And if you got one that works real good, that's worth knowing about.
Or if you have one and you have a lux sensor to figure out how much sunlight you're actually talking about.
Yeah.
Is there a way to copy a short URL from Amazon, or just copy the whole thing?
Either way.
Go either way.
It's just a generic cheapie.
Oh, that's not as long as the one that Ted put in. You're just a piker, Pat. You shouldn't be worried about that. Let's see what that is. Oh, let's see.
That's just one of the first ones I saw.
Yeah.
Yeah, I kind of get the impression that they couldn't handle strong sunlight.
There was a couple of problems, I think, with this particular one. Isn't this the one that that they don't have you can't change the address. Can't.
Yeah, there's ways around that though. That's easy with the multiplexer.
Yeah. Yeah, you have to use a multiplexer with this one.
Yeah, on my indoor wooden monster, I have a multiplexer and I'm using 2 at the front.
Okay, that's good. Because I know there was another solution where you essentially turned one sensor on and then used the inhibit and turned it off and switched to the next sensor. I tried that and it didn't work very well. I mean, I could get it to work, but it didn't seem very reliable. It was a pain. Yeah. No, the one I would probably use is, if it's a lot simpler and easier, is that polo sensor.
Put a link into that?
Yeah, let me get it.
Like I say, I'm just looking to pick up whatever, logs, brush.
Yes, I still don't remember any of those saying that they're recommended for outdoors. I mean, maybe there's an exception to that, but I thought they were strictly for indoors.
Well, I do know that David Anderson used the sharp distance sensors. They're a little slow, but he did use those. And the one I like is this one, right?
Those sharp sensors used to be everywhere. You could find them all over, analog, digital, all sorts of versions.
Yeah, I want to say this one is the one that I prefer. They do have one that'll go at a slower rate for up to 3 meters, but this one will do 1.33 meters.
That's still over 5 feet.
Yeah. And what I like about it is that it has a pulse width output.
Kareem put a link to one as well.
There you go.
Yeah. Yeah, but that was a Maniwaki, isn't it? Is it?
I don't know. It looks like maybe they stuck a Maniwaki in a box. Maybe. No, I don't know.
Well, I mean, Maniwaki's got, a whole series. You got the Money Honey, they got the sensor.
Strong ambient light. Yeah.
Let's see, what is this one? Mm-hmm. Yeah, this one, okay. This one says 100K lux. So the one that Kareem put in is definitely outdoor.
Yep.
Narrow field of view, 1 to 2 degrees.
Yeah, that's the thing. Gonna have to stick it on a servo.
Yeah, I'm pretty sure that's a Maniwaki. The reason why I say that is because they show alternate sensors, and those are all Maniwaki. Well, that's cool. That's a good link. Thanks, Kareem. Did we reach that point, guys?
Probably have.
Maybe it is.
Yeah, that
It's
looks
almost-
like a good one.
Yeah. It looks like 9:30. Does everybody saying goodbye? Okay.
Thanks for
All
links,
right.
guys.
Okay.
Take care.
Hopefully next week we'll have some updates on some of the Robo Columbus type parts. That'd be kind of cool. Okay. And Paul, you need to reconsider your priorities.
You're right, Doug.
Okay. Adios, guys.
All right, good night.
Thanks again.
All right.